it do, baby? I make sure I hit the mute button this time. It's your boy, the network, in the building. We got my man Pete S. showed up to class on time today. We got Abdel Bassett from where you from again? Egypt, right? I think you tuned in from Egypt over there. Today we are going to be configuring NTP, which is Network Time Protocol. We're going to give it some time for some people to tune in and get on right with the show. This is just going to be a quick lab. I kind of skimmed through it real quick, and it's like there's only one router. I don't even need to put a topology to explain this topic for you guys. I mean, if you know anything about NTP, it stands for Network Time Protocol, and it is used to synchronize the time within our network. So, and time is crucial. It's very important. It's important in real life too, right? But in the network, it's super important. So, for example, if the time on your Active Directory server and your PC, if they don't agree on the same time, then you won't be able to log on to your domain. Well, the same thing can happen with the network infrastructure. Well, that's pretty much network infrastructure, but we can use our Cisco routers or switches as an NTP server, whereas the other devices that are connected to it, maybe another router or another switch, can be used as a client, an NTP client. That way we all agree on the same time. So, and this time is very important. It's important, like for example, if you look at these logs right here, this is me just booting up the router, right? And notice we got a date and time stamp right there, right? If that stuff is wrong, right? Let's say the router crashed. Let's say we had this interface go down, and this was our main wireless, or wide area network connection. If we see it went down right here, right, and it says it went down at 23:36, well, the time right now is technically 8:02 p.m. Eastern Standard Time. So this time is wrong. So that's very important for us for our logs and stuff like that. We need the correct date and time, and that's what the point of NTP is. So. Again, we're going to give it some time for some people to log on and stuff like that, or tune into the stream. I know some people be tuning in real late, or some people just stumble upon this when they type in like, I need some information on the NTP. I got a test tomorrow, and I don't know anything about it. And then they run into this dude named NetworkBruh teaching us about it, right? But this lab, I'm a big fan of this book. In case you guys are tuning in for the first time, y'all know this is the lab guide that I typically use for these live streams that I've been doing, or AKA the LiveLabs. It's called 101 Labs, Cisco Ccna version 4. You can get a copy of this from 101labs.net. There's also a link in the description box below, right? It is a Amazon link, so it is an affiliate link, right? I get commission if you do get it from there. However, this lab, they only had one router on it, and there was only like a couple tasks on here. So, and it does not, and obviously this book is just a lab book. They don't go too deep into the theory. They don't even teach you any theory in this book. So I just didn't like, I'm not a fan of this lab right here. We might be able to knock this out in like 5 minutes if I didn't talk so much, right? But yeah, I'm not a fan of this lab. He only had 4 tasks. He does not really challenge you on setting up NTP. But then again, right here in the lab, if you got the book, it's page 322, lab number 71. He has an important note. He put it in bold there. It says, in order to test NTP, you will need to be connected to an actual NTP server that you will probably not have with a home lab or remote rack. So again, we're going to have a server that says, this is the time, right? Like right now, let's say my laptop was the server, right? Right now, the time says it's 8:04, right? Anybody else that's connected to him will be the clients, right? These clients will receive their time from that server. If the server says the time is 8:04, guess what everybody else is going to believe it is? It's 8:04, right? Now, the problem is we don't have an NTP server. We're going to set this router up as an NTP server, but he doesn't set anybody else to be as clients. That's why I'm not a fan of this lab. And Prowl Browning, if you're watching this book, if you're watching this stream, why did you not put any clients or actually any servers on here? You just set them up as a client and that's it. He didn't set up anybody as a server and have them sync their time or anything. So he does not challenge us with this lab. He only has 4 tasks with this. Let's go ahead and I guess if y'all want to get started right now, or I'm going to give it a little bit more time. Y'all know I usually wait for about 10 minutes. But yeah, run me with that like button if y'all don't mind. We got Dave W in the building. What's going on, Dave? Yeah, I'm not a big fan of this lab right here, man. We might be able to knock this out like really quickly. and maybe be able to knock out this SNMP lab in the next book. I mean, in the next lab, because I said I wanted to try to knock this book. I wanted to get through this book, man. I wanted to get through this book and start doing some CCNP stuff. Again, let me give you guys some information while we wait for some late stragglers to come in. Yeah, I know there'll be some people that come into class late. I'm just the instructor that just lets people walk into class late. If you guys are just tuning in, if you're using Packet Tracer or even G or any other, if you're using real hardware, we only need one router for this topology. That's why I don't have any. If you notice, normally I have a topology sitting up here somewhere, but I don't have one because we only need one router. Maybe for the next lab, if I do have time, we'll do the next lab, which is SNMP, and I'll give a brief description on that, and then we'll probably do that. But here is a guide for best practices on NTP. Do I want to get this to y'all? I don't know. This might be a little too much info. Yeah, this is a best practices white paper. I'll give you guys. I was going through that guide. If y'all want, I'll go ahead and leave that in the chat box there if y'all want. I also don't like how a lot of labs use serial links. Agreed, Pete. Agreed. We got Lee McMillan Bill. What's going on, Lee? Thank you for tuning in, man. Y'all run me with that like button. But yeah, I agree, man. I don't like the fact that he just puts in a lot of serial links when we know that serial is going by the wayside. We're now, nowadays most companies are using fast Ethernet, gigabit Ethernet, 10 gigabit, even 40 gigabit Ethernet, even 100 gigabit Ethernet links. So I don't know why they did that with this book, but yeah, this is one lab. We're at lab number 71, so I guess he did 70% of the book. I pretty much liked because he really challenged us. I got stuck on a couple labs. We got the Fat Finger Squad over there to help me out. But again, if you're just tuning in, we only need one device. So if you got Packet Tracer, even G or whatever, just drag and drop one router. I'm going to be using a real router here. So let's go ahead and get started, right? Go ahead and change the host name to router 1. I hope you guys know how to do that. If not, then I can show you guys. Is this the network time protocol? That's correct, Lee. I kind of explained it at the beginning, but anyways, NTP, as I mentioned before, is a protocol that we use to have all the devices on our network agree on the same time. If we have some devices that say, no, it's not 807 right now, it's actually 907 right now, then we can have a conflict. It can cause all kind of issues on the network if our devices don't agree on the same time. One prime example would be an Active Directory server with a PC trying to log on, with the PC trying to log on to the Active Directory server, right? You put your username and password. It's not going to let you on because you'll be like, you have the wrong date and time. As a matter of fact, I remember using a two-form factor authentication. Which one was it? I want to say it was Okta, and it was to get the VPN working on my laptop for my work computer, and it would not work for some reason, right? The two-form factor would send the code to my cell phone, my personal cell phone, right? And for some reason, I was like, I know I set it up, man. I was like, I started to call the IT department, and I worked at a NOC, right? And I was sitting here trying to get them to help me out, and I'm like, I think I figured out the problem. I used to put the time on my phone 1 hour, not 1 hour, about 15 minutes ahead of the time just to get me to places on time, right? And once I fixed the time on my cell phone, I was able to get the two-form factor code on my cell phone and finally log onto the VPN. Simple issues like that let you know that we need to have devices on our network to agree on the same time. And that's what NTP does, right? So, and Dave, I guess that answered your question right there. What are the benefits of it? It's so we can, it's for shit to work, man, because things need to be agreeing on the same time. And like I was mentioning earlier before in the stream, like when I first logged on or first streamed, right? Let's say like this router right here, I just powered it on, right? I actually rebooted it, right? And we have these log stamps right here. We got this date and time stamp right here. We got this configured by memory, blah, 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 right? And it tells us the version, what time we restarted, and all of this stuff, right? Right here, let's pretend that this is our wide area network connection, right? Our network connection that we used to basically get on the internet, right? That FA01 port, right? Right there. Right there, it says it went down. And let's say it happened last night, right? And we woke up and we're just like, oh shit, the FA0 interface went down, right? We can see what time it went down, right? Oh yeah, it went down at 23:36. Well, guess what? I rebooted this router about 10 minutes ago. And you know what? 10 minutes ago was not 8:10, right? So right there, it tells us that's the wrong time, right? So that's what we're gonna do here. We're gonna actually fix the time and use NTP. But he does not really challenge us in this lab. He only has us set the router as an NTP client, and that's what we're going to do here. Remember, we need a client, to talk to the NTP server who has the time. The server has the time. I'm going to say that again. The server is the guy who has the time, who gives it off to the clients. He says, hey, look, y'all, the time is 8:10. Everybody else is going to be like, oh, at the time is 8:10. Let me go ahead and put my date and time as 8:10, right? And April 29 or whatever. Another fact that you want to remember is the stratum, the concept of stratums, right? You know anything about atomic clocks and GPS clocks? Those are clocks that are around the world. They have the most accurate time in the world. They're placed everywhere, like not everywhere, but there's like some in Alaska. I can't remember. Let's just Google it real quick, right? Just a real quick fun fact about NTP. And he doesn't say nothing about this book, but then again, this is not a theory book. So let's do atomic clock, right? I don't know where they at, but I know they're around the world, right? Atomic clock locations. We can do locations, right? So we have the Boulder one, the one in Boulder, Colorado. It's the clock that sets them all. If you ever wondered what clock sets the official time of the United States, this is the main NT. This is the atomic clock located in the United States. It's in Colorado. This is like the most accurate time, not in the world, but in the United States. That's the clock that we refer to, right? Where are they located? This is what I was trying to ask here. We got one in Boulder, Colorado. We got one in the Air Force Base in El Paso. We got one, I think that's another one in Colorado. We got one in Washington, D.C. Here's 17 more, right? This is the list of the atomic clocks, right? We got one in China. Anyways, those are the clocks that they have the most accurate time in the world, right? And we set those as reference points when it comes to the time. We need to know the time. Yeah, like you have the time on your watch, right? But that's not the most accurate time. The most accurate time comes from GPS clocks and atomic clocks, right? Well, how far you are away from the atomic clock is called the stratum, or each hop away you are from the stratum, right? So let's say we synchronize our time to, and I don't know the IP address of it. Let's say we synchronize our time to the Boulder, Colorado one, right? This is the clock that sets them all, according to Google, right? Let me see. He says, so for example, firewalls would depend on, everything on your network would depend on NTP when they need to set their time, right? You can have an NTP server local on your network, right? And have everybody else report to it to get the time, right? But the most accurate time clocks in the world are the atomic clocks. That's why you want to kind of point them towards them. But for security reasons, it's best to have one internal in your network, right? So let's say we have this one in Boulder, Colorado, right? And we use that as our NTP server. Like, let's say his address is, I don't know, 199. Maybe, is there, what is the atomic clock, Colorado, and let's just do IP address, right? And we'll save that for the lab too, right? So this is the IP address for the one in in Colorado, right? So let's say we are 5 hops away from it, right? That means our stratum is 5. So we're 5. It takes us 5 routers before we get to this IP address. We're 5 hops away from it. That's the stratum you want to set it to, right? But he doesn't go over the concept of stratum and stuff like that. I'm just kind of explaining it to y'all. That's another reason why I don't like this lab. He didn't get into any of that stuff, right? So that's how many hops you're away from. The stratum is how many hops you are away from an atomic clock or from the NTP server, the most precise time in the world, right? So let's just go ahead and get with the lab. Enough for lecturing here, man. Like I said, he didn't get too deep into the concepts of stratums or servers. He just has you set up a client, and that's it. The objective is to configure a router to access the time from an NTP server. So we're going to save this IP address, right? We'll save both of them because I think he sets up 2 for us in this book. NTP is an important tool used by Cisco equipment to ensure the devices share a consistent time, just like I mentioned to y'all. It is also used to add accurate timestamps to debug messages. These motherfuckers right here, just like I said, these debug logs right here, these log messages, as long as we have the correct date and time on these, then this will be considered accurate information to us, right? This is obviously not accurate because my home rack, my home lab is off the grid. So I don't have an NTP server it's pointing to it. It's not on the internet, right? So y'all can't hack into my shit. But anyways, task 1 is to configure the host name, which I'm pretty sure you guys know how to do, right? Y'all want to do that? Do y'all need some help with that? If not, I mean, just follow along. I've already gotten this guy labeled as router 1. Y'all know how to do that though, right? Configure terminal, right? In case there's any newbies in here, I'm not going to do this very often, right? So host name, R1. Now he's R1, but he was already R1. I'm just showing y'all how to do that, right? Task 2, set the clock manually to any time zone and time of your choice. Well, guess what? I'm going to pick this time right here, 8:15. Also, these clocks are done in military time, so you got to kind of know that too as well. I used to work for law enforcement, so that's how I kind of know the military time by heart. But anyways, set the clock. The way you do that is just clock. That's a simple one. Clock, and then time zone, right? I used to think it was clock set, but it's not. Oh, but they said the time zone. That's what it was. But if you want to set the clock, though, that's what I wanted to know. I thought it was set. No, it's not. Maybe you got to do it in privilege mode. Let me see. Or privilege exact. Set? No. Clock? Yeah, that's how you set the time. You can set the time that way. But we're gonna check that's not what they asked us. They asked us for the time zone and the time of our choice. Oh, so there you go. Time of our choice, clock set. So that's right. I was right. I'm just jumping over here. The time is 8:16. So in military time, that's 2016, right? So we're gonna say 20:16, and we'll just put 00 for the seconds, right? Right. Oh, what else we got to do here? Oh, and then we got to put the date, because they said the time zone and the time of your choice. So you can't just set the time. We got to set the date as well. But let's verify what we got so far, right? Show clock. We have 0009, right? So it started at basically, did I start this 9 minutes ago? No, I'm pretty sure I rebooted it longer than that. But anyways, they're saying that's the time. That's obviously not the correct time. The correct time is 8:16, right? Then we got the date and time. That's correct. It probably got it from the clock on my laptop. I don't know. Who knows? But we're going to set the time, right? So clock set 20:16. They also want the date, though. Seconds, 0. We're going to say the day is the 29th, right? Today is 29th. And then what else they want? The month, which is April. And then the year is 2021. Right? So now we do that with show clock. And notice right there, it says system clock's been updated. Right? But we show clock. And we see now we've got the correct time, right? But we manually set the time there. That's what we did there. So now let's set the time zone, right? And the way we did that, well, you got to go global config mode for that. So global config mode, and you're going to say clock time zone. And I'm in the Eastern time zone. Because you guys don't know, I'm in Florida, right? So Eastern is just, the code for that is EST. Whatever time zone you guys are in, if you're in Pacific time zone or whatever, you got to know the three-digit code. You might have to Google that. So I know that EST is Eastern Standard Time Zone. And then you got the offset time. The offset time is how far you are from the UTC time, which is what? Universal Time Coordination? I forgot what the hell that meant. Let me not pretend I know, right? UTC meaning, right? In time, it is Universal Time Coordinated, right? Greenwich Mean Time, but it's now referred to, they changed the name of it. It used to be Greenwich Mean Time. They changed it to UTC. It's a coordinated time scale, right? So it's like the how do I say? Like the main time location, but you want to know how many offsets, how far you are away from it, the time zone, right? Well, I'm in the Eastern time zone. We're, I think, 5 hours away from UTC. So you got to put in, and mine's is 5. So 5 offset, or is it -5? I want to say. Yeah, -5. Because I'm 5 hours behind the UTC time. And then how many minutes? I'm just going to put 0. And that's pretty much it. That's how you set the time zone. I was kind of confusing. If you don't know too much about, if you're not well traveled, or if you don't know too much about time zones and stuff like that, this might be a new concept to y'all, man. So anyways, clock time zone like that. And let's see, right there, changed the updated time again. But see, it changed me to 3:15, basically 3:17, and it kept me on the same date. But yeah, basically it put me back. But we should have manually set that. This I'm not really connected to a network. Like again, my home lab is off the grid, so I can't sync it to any how do I say, NTP server or anything like that, right? And as a matter of fact, that's what he says in the book. In order to test NTP, you will need to be connected to an actual NTP server that you probably will not have with a home lab or remote rack. So even if you're using EVNG, you won't be able to synchronize the time and stuff like that. So anywho, task 3, configure router 1 to access 2 NTP servers. Well, guess what? We're going to use these 2 servers right here, the ones that are in Colorado. But again, my lab is off the grid. It is not on the internet. So I'll be able to put these IP addresses. I'll be able to point it to the servers, but I'm not going to be able to sync my time to it. So the way you do that is go to global config mode, and it's a simple command, NTP server, question mark, it's going to ask you for the IP address. What was the IP address? We're going to say that guy right there. But in the book, he says configure router 1 to access 2 NTP servers. So in case this guy right here fails, we'll be able to fail over to the other one, or maybe we can pick one as our main one, right? So we'll pick that guy, right? Copy, paste him, and then we'll just press enter. And we want a second one, so server, and then we'll put this guy, right? If we question mark 2, what else we could do? We could do this iBurst, this key, max poll, prefer, and all this other stuff, but they ain't ask us for all of that. We could also change the version. There's about 4 versions of NTP. Or is it 2 versions? I don't know. Let's double check. We'll remember, this is my learning journey. Y'all learning along with me. NTP versions. How many versions are there? The current protocol is NTP version 4. Is backward compatible with version 3. So what happened to version 1 and 2? That's my question for y'all, right? Let's see here. Versions. Control F, versions. Oops, version. Let's see, NTP version 4. Backwards compatible version 3. There was an NTP version 0 when it first came out. So here are the versions we got right here, right? This is the RFC evolution rather. This is the guy that pretty much designed NTP. This brother right here, David Mills. Shout out to you. Is he still around? Let's see. I guess so. Yeah, smart dude, huh? But anyways, he is the inventor of NTP. That's good. That's another fun fact for y'all. Ccna exams they're not going to ask you who invented NTP, but just know that they'll probably ask you what is the current version, or let's see, what is made. They're probably going to ask you the difference between, and this is the stratum concept that I was telling you guys about. When you are connected to a NTP server, your stratum is 0. Right? Stratum zeros. Oh, no, I'm sorry. These are the stratum 0 devices. When you are connected to it, you are stratum 1. Right? Whoever's connected to you, they are stratum 2. Stratum 3, so on and so forth. That's exactly what I was explaining to y'all earlier. This book don't go over that. He don't even configure anything with stratum, because he sets it up as a client. That's why I don't understand. Like, usually Paul Browning challenges us with these labs here. But I was trying to see how many versions. I guess there were just 4 versions. There was, version 2. Yeah, I guess it's version 1, 2, 3, and 4. And 3 and 4 are backwards compatible. We need to know what the difference between these two. I want to say, okay, version 4 has authentication, so you can set the passwords for it. That's another thing too. If you guys have Boston NetSim, which I'm still in talks with those guys to give me a copy of it, they really challenge you on NTP servers. They have you use Ntp Authentication. You know, in case you want to, you have your client, you want to get your time from the NTP server, you have to know the password, so we can set up authentication with NTP. He don't do that in this book, man. What's up with you, Paul Browning? Dave said, how would organizations configure an NTP server to bridge over to an atomic clock? Easy, the same way we did this right here. NTP server, and then you put the server, the IP address of the atomic clock. However, you just have to have an internet connection. My home lab rack is off the grid. It's not connected to the network. If I actually had a network connection, plugged it up, I would be able to ping that server right there, right? Ping this guy, and then and sync my time to it. And then once we sync our, see, I can't even do that. Ping, recognize. Yeah, so he's not even running. Why can't I ping it? Show IP route real quick. Yeah, I don't even have a route to it. So there's no way. Even if I set a static route to it, I won't be able to get to it. So either way, I don't have a routing table like this. I just rebooted. This is a clean router. So, but anyways, if I was connected to it, obviously I would get a reply from that, and then I would be able to sync my time from it. How do we verify that? We do show NTP status, and right there, clock is unsynchronized. If we was able to connect to that NTP server, this guy right here, the Colorado one, right? This would say clock is synchronized. Stratum 16. Does anybody know why that says that? I know I just explained it, and maybe maybe the stratum concept is new to you guys, but why does it say stratum 16? When I said that this home lab rack is off of the grid. Am I 16 hops away from the atomic clock? And notice it says here, no reference clock. So that means I don't have, when I'm connected to, like, let's say if I was able to actually use this guy as my reference clock, or I actually can synchronize my time to him, this would say synchronized. This would say how many hops I'm away from it, but it says 16. That's weird. And this would say the IP address of who is my reference clock. Who am I synchronizing my time to? This is some other I ain't gonna say superfluous information, but this is really like deep stuff. NTP can be really a deep subject. How many times we're offset from it, root dispersion and stuff like that. You're not gonna get tested on this on not no Ccna exam. No, maybe CCIE even, but I doubt they'll even ask you stuff like that. They don't get that deep in the NTP. But anyways, 16 clocks globally. Good guess, Dave. No, but basically we're 16 hops. It says 16 hops away. That is similar to. You know how the RIP protocol is, whenever something is unreachable, it sets the, I forgot what that concept was called, but it sets the maximum hops to 16, meaning it's unreachable. Like, I can't even reach it. Anything past 16, I can't even reach it. That's basically what this is telling us. We're 16, it says 16 stratum. This is kind of like the maximum amount of hops. Anything past beyond that, it's unreachable. So same concept as RIP. I forgot what that concept is called in RIP, but let's see. Let's see. I'll Google it real quick. Look at me Googling on live streams. But you know, this is how you learn. You're talking about something, Google it real quick, reference it. Right? I'm doing this freestyling with no PowerPoints and shit. Right? So maximum hop counts exceeded in RIP. Right? Boom. Maximum hop count is 15, actually. Networks with a hop count of 16 or more are considered unreachable. Same concept with NTP. If you go beyond 16, or actually pretty much 15 stratum away, then you can't even reach no NTP clock. This, obviously, my home lab rack is off the grid. It is not connected to the network, so that's why I can't ping an NTP server or synchronize my time. So, but good guess, though, man. Pete got it correct. Metric hop count. So the metric is hop count, yes, and that's how far I'm not 16 hops away. I'm more than 15 hops away. So therefore, an NTP server is considered unreachable. So same concept with RIP. The same concept with RIP lies with NTP when it comes to hop counts and stuff like that, right? So what was the last task? Configure the two NTP servers. We did that, right? But notice we don't have any time, or it says no reference clock, even though we're pointing to two servers, right? Did we point to two servers? No, we pointed to one. The second one was the other one in Colorado, which was what? Where's he at? Where they at though? Where was he? He was behind this guy. Behind that guy. That was the second one we was going to use, right? The other one in Colorado, right? When y'all get a chance, you know, reference, you know, or like kind of research the NTP clocks that are, or atomic clocks that are around the world, and see what happens when we try to sync to them and stuff like that, right? And if you do have a home lab rack that you actually have connected to the network, see what happens when you can synchronize to a clock, and notice the difference there. But anyways, Boston NetSim has good NTP labs. Global config mode, NTP server. And we could say, we put that IP address of that server. Oops, I copied the wrong stuff. This is the guy I wanted to copy. Boop, boop. And then we could say prefer, to say we prefer this as our main NTP clock. In case that one dies, then go ahead and fail over to this guy, right? Prefer, right? And then we verify our work with show NTP status, which obviously I'm not synced to it, so it's gonna say no reference clock, right? That's what I don't like about this lab here. And he says here, task 4, this is the final task of the lab. How did you challenge us here, Paul? I'm gonna need you. When next version of this book, I need him to do something more with this lab right here. Task 4: verify your NTP configurations with the appropriate show commands. Well, the appropriate show command was show NTP status, and what else he did? He also did show NTP associations. That's the other one I forgot. So show NTP. If I could type associations, and there's our reference clocks. That one that we pointed out before. That one pointed out before. But notice we got a little. We got a legend here, right? Notice this little, I forgot what that mark was, what that stood for again. What does that mean again? That is a, but it actually means that it's configured. So we configured this to our NTP server. And then this one is our other NTP server, right? If you see this right here, it says this is a peer, right? When it's a peer, we are the master and we have peers, right? And you'll see an asterisk beside it, right? We'll have a candidate selected, etc., etc., etc. What is that symbol called again? I don't want to give that as a symbol. What is that symbol called? What is that symbol called, y'all? I forgot what that symbol is. The squiggly mark right there. But anyways, that squiggly mark means it is that is configured as our NTP server, and that's who we're going to point out our time to. Stratum is 16 because it's unreachable, right? If we're 2 hops away, just like we said in this, where was it? Bloop, bloop, bloop. We were talking about NTP. Where are you, NTP? See, we are. If our router was here, we are 3 hops away, or 3 stratum. Our stratum is 3 away from the clock. So 1, 2, 3, right? But this one, we are 3, 4, 5, 6, all the way to 15, 16. So it's considered unreachable. That is why my stratum is 16. We can manually set the stratum as well with NTP. See, he don't even get any of that stratum, right? Isn't it stratum? Nope. How do you do it again? I forgot how you set the stratum. Peer source server. There is a way to set the stratum automatically. I mean, manually. I forgot how to do that. We can set him up as a master clock. Maybe we got to set him up as a server and then do that. Master. There you go. That's what you got to do. You got to make him the master and then tell him how many hops away you are from an atomic clock. And then you can say, let's say we're the master and we're 3 hops away. And then that'll let you know, that'll let them know, everybody else know how far they are away from the atomic clock, right? So that's pretty much it for that lab. I think, do y'all want to knock out the Snmp lab? Y'all want to knock that out? Y'all let me know in the chat if y'all want to knock that one out. But we pretty much done with that lab. He did NTP Stratum. Oh, and that's what he did too at the end of the book. I mean, at the end of that lab. He said you can add another router and configure it as an NTP server with the command below. And that's exactly what he did. There you go. And then he talked about he even put the Stratum number on there too, but he didn't even explain or anything, didn't even talk about Stratum or even challenged us with a Stratum task or anything like that. So, but anyways, in case you guys want to follow along next time, get you a copy of this book, 101 Labs Cisco Ccna version 4. You can get a copy of this from 101labs.net. There's also a link in the description box below. Also, that link is an affiliate link. So I do get commission if you do get it there. Experts agree that we retain only 10% of what we read, but 90% of what we do. That's why I like this book, because we at least read all this theory from Google and goddamn Wikipedia and shit, right? But we're not going to be able to practice NTP until we have something to hands-on practice with, right? So I have my router. You guys have EvenG and Packet Tracer, or maybe even hardware, but we need something to follow along with. That's what this book gets us to do. When we're done with this book, we're going to move on to the CCNP topics. He said tilde. I'll pronounce tilde. That's good to know. Fun fact of the day. Shout out to S-Move and Pete for telling me that, because I did not know that's what that was called. Tilde. I cannot assign 2 servers in Packet Tracer. Unfortunately, Abdel Bassett, Packet Tracer is very limited with its commands. That is exactly why I use hardware, because we're using the exact iOS and it gives us all of these features here. It's going to be really limited to what you can do. You can I don't even know what NTP servers commands that you can do. I know you can just set up an NTP server, set the date and time and stuff like that with Packet Tracer, but there's some commands that are missing in Packet Tracer. They give you just enough to pass the CCNA exam. But yeah, Kobe says let's knock out the Snmp lab. Yeah, let's do that, man. Let's do that real quick, man. Let me just get a copy of that. Topology. It's real simple topology. And I'm going to use Packet Tracer for that one. Am I going to use Packet Tracer? There's only 5 tasks for that book, for that lab, so I'll use Packet Tracer. I ain't going to use this guy right here. So let's go ahead and I'm going to launch up Packet Tracer just for Abdel Bassett, so that way we're on the same playing field. But I can turn off my routers. Y'all could turn the, get rid of, ignore those fans there. You guys know anything about Snmp? What am I doing here? Snmp is Simple Network Management Protocol. You goddamn acronyms in the IT field, man. But Snmp is a way for us to get alerts from our devices or receive alerts from our devices, right? Anytime something's wrong with it, I like to compare it to the lights on the dashboard of your car. Right? You know how you got the check engine light to let you know you got to check the engine. Something wrong with this motherfucker, man. Right? Or if you have the low fuel light, right? Lets you know, boom, it lets you know, hey, you're low on fuel. Or you get another light saying, hey, your tire is low, right? That's how SNMP works, right? SNMP lets us know if our power supply is down, right? SNMP lets us know if we have an interface going down, right? SNMP lets us know if somebody unplugged the cord, etc., etc., etc. That's what SNMP does. However, SNMP is kind of like the language between the actual part or device, like let's say the power supply of our router, and the interface, like our computer, right? So whenever the part goes down, like let's say a power supply goes down on our router, boop, right? SNMP, it'll send what's called an SNMP trap, and then the trap will come to your laptop or your computer and let you know, hey, the power supply is not working anymore, and hey, the CPU is bogged down right now, right? Like this system is really hot right now. We need to do something about this. SNMP is basically the language that allows you to interface between the part or the component of your router or switch or device versus between the part and your computer. So that's basically what SNMP is. Basically the language that allows you to talk to that part or the part to talk to you, if that makes any sense. Y'all know I keep it simple, man. I try not to use big words and shit like that. I just make it real simple. So we only need one router and one server. So let's go ahead and drag and drop. I like the 1941 router. They placed it over here. And we need a server. We are going to place that guy right here. We're going to connect it from gig 00 to gig 00. So let's get a cable up. We're going to have a fast Ethernet interface, gig 00. Configure the host names on router 1. So let's go ahead and power up router 1. CLI. It looks like he's already powered on. No. And enable. We're going to change the host name to R1. Y'all with me so far? Anybody got any questions or anything like that? Only one server. Yep, that's it. That's all we need is one server. So this should be a quick and simple lab right here. Knock this one out. Y'all typically, I typically do one lab in these video streams here, but I just want to knock out this book because I want to get back to my CCNP studies, man. But so we got one router, one switch. We gave him the host name. Task 2 was to configure the IP addresses on the interface of the router. So this guy right here, in case you guys don't have the book, I'll go ahead and do some labeling for y'all. Don't rely on this for too long, because once we get to the CCNP book, I'm not gonna be waiting on y'all like this 1.1, right? And then y'all can, just in case somebody need to follow along, they ain't got the book, right? Get out of this right here. All right. So that's gonna be that IP address, right? I'm just doing that for anybody that don't have the book or whatever. So IP address, where we need to go to interface GI00. Give him the IP address of 192.168.1.1. Subnet mask of /24.0. Let's go ahead and no shut that bad boy. No shut. And he is powered on. We got some red lights or green lights. That should be good. Let's make the server 1.2/24. So we're gonna go to config mode or config, and then go to the fast Ethernet. Give him the IP address of 192.168.1.2. Oops. Whoop. /24. Tab over, and it should fill out the subnet mask automatically. Task number 3: configure an SNMP v3 group. Hopefully, Packet Tracer supports SNMP version 3. Now, y'all know I said Packet Tracer is a simulator. It is not an emulator. In other words, it doesn't have a full version of iOS. You got like basically a fake router with, a fake interface just to kind of get you the feel of how to use iOS and stuff like that. Most of the commands, a lot of the commands are not supported on here. So let's just hope and pray to the network gods that SNMP is supported on this iOS. So let's go sit. Let's see what it says here. Task number 3. We only got 5 tasks, and we can knock this out, right? Create an SNMP group that uses an authentication and encryption named read-access to provide full read permissions. Make sure only the 168.1.2 server, which is this guy right over here, can access this SNMP3 group. So remember, with SNMP, remember what I said SNMP is, right? Simple Network Management Protocol is the protocol that we use to get traps or messages between the device and our management station. So let's say our server is our management station, right? let's say, remember we said we have a part, let's say our power supply, right? Let's say the power supply goes down on this, or let's say the CPU is going too high, or we got too much utilization on one of these interfaces right here, right? We're going to send a trap. So that device is going to send a trap to the server, and the server is going to go, oh, the power supply is down, right? Because he got the trap from the SNMP. Well, we need to set up SNMP to basically get these two to talk, right? Now, the thing is, you can have users, right? Let's say we had another SNMP, like, I don't know, a server or another user right here. We can use that to receive information from this. So he'll send a trap to this guy. Who else is going to receive it? That's what we're going to do here, right? But we're only going to have one server. So he is going to be in that, that group. We're going to have users within a group. Whoever's in that group will be able to get information from this router, right? SNMP messages from the router, right? That make any sense? So, what else I haven't even got to that task. I've been sitting here explaining. So, create an SNMP group. So, what we do that is, I can't even remember. And what crazy thing is, I had to set up, upgrade SNMP at my job here, my current job, is SNMP. Most of the SNMP commands start with SNMP-server, right? We can question mark our way through this and use logic to kind of go through it because I don't know the commands by heart. And luckily, the Ccna exam does not have simulations, so you don't really need to not memorize them by heart, but they want you to at least be able to examine the output and read the, show commands and stuff like that. So what are we going to do here? Community, right? We don't want to do a community. We really want a group. And I don't know if this supports groups. Right? SNMP community, they didn't ask for the string yet or anything like that. So let's see. We should be able to do the group here. It should be SNMP and then the username and then the group. But right here, he says he wanted us to set the group. That was task 3. Let's see. I don't know if it's because packet tracer is... Let me see. See, I should have just used my real router. I was just like, I wanted to be able to talk to this server and stuff like that, but hopefully it is. Let's see. Let me look at the solution. That's another thing about this book. In case you don't know some of the stuff, there's a solution right after the lab, right? So you'll know, you'll know if you can do this or not, or if what you're missing. And just as I suspected, we won't be able to do this lab with packet tracer because you need to set the group. And it's access create the access list. So you can set up the access list, but you can't create the group. Because see, typically you would be able to do SNMP server and then group right here. So looks like I'll have to fire up my real router. And I do have my real router powered on still. I just didn't have my terminal server up. So I'll leave that as a topology so y'all can at least see what we're working with. The other thing is, yeah, see, we won't be able to even test SNMP with it. We'll just be able to create the group. Here's another lab I don't really like about this, but then again, he does not expect people to have extra stuff on his lab, like SNMP servers or Ntp servers. So there's only so much he could test us with. Let's go ahead and power up as secure CRT. And let's see, it was router 1. It is booting my router's already booted up. What I needed to do is boot up my terminal server. We should hear it pop up in a second. Matter of fact, let's look at my terminal server. See where he's at. That'll give us a good idea of when the router is booted up. So yeah, I don't think you guys could run this lab in packet tracer. I was just trying to level the playing field there, man. And it's Ccna. Need you just explain how SNMP operates? I mean, that's pretty much how I explained it, basically, man. It's just a language that allows the device to talk to the SNMP management or server, right? So we'll go ahead and try to set it up here, though. They send, like I said, it sends traps to the device, to your server or the management console, If you need like more theory behind it, I have an SNMP video on my channel. So go on my channel, Abdel Bassett. You'll see, just type in SNMP, NetworkBruh. I've got a video explaining a full breakdown on SNMP. This is just a live lab that I'm doing here. So I have full tutorials on SNMP if you need that kind of explanation. I just gave a quick run explanation right now. So, and I wanted to knock this out real quick. So create an SNMP group that uses authentication and encryption named read-only read access. So SNMP group, let's see if it works on here, right? SNMP server, SNMP server group. That was the command that I was looking for in Packet Tracer. And see what I meant, Abdel Bassett? You can't, like, Packet Tracer is very limited with its commands. There's only so much you can do with it. They give you just enough to pass the exam. There's some things that are just not available on Packet Tracer. That's why you need GNS3, EVE-NG, or real hardware. So this is a prime example of that. So what was the group we wanted it to name? He said to name the group read-access. First letters caps, right? Group, question mark. What's the name of the group? Read-access. We question mark again. Obviously, this is Lab 72, page 325, version 3. So that's what they said. Here's version 3. That is the most secure version of SNMP, if you guys don't know. Version 1 was not very secure. The passwords and authentication is done in clear text. Matter of fact, I don't even think authentication is supported on. Yeah, I think authentication is supported on version 1, but it was done in plain text. There was some more improvements with version 2C, and then version 3 is the most secure and current version of SNMP, right? Remember, SNMP is basically just a language that you use to talk your device with the SNMP console or server, right? So what was the next thing we want to do? Auth, no priv, or priv. Well, guess what these are, right? Auth allows, basically that's short for authentication if we want to use a username and password. Well, this said here, they wanted us to use authentication and encryption. So this is no authentication, no privilege, or privacy. So that's basically, we don't want no authentication or no privacy, no encryption, basically, right? This is privacy, so encryption. This is both authentication and encryption. So we want auth. That's the key word we want there, right? That's all you need to remember. Well, it's not all you need to remember, but this does privacy, basically authentication and encryption. This is no authentication and no encryption, and this is just encryption, no authentication. So, right? I said that correct? Yeah, I think I said that correct. Correct me if I'm wrong, though. So, question mark. What else they wanted us here? Do we want to match anything? Read. They said they wanted uses authentication and encryption. Provide full read permissions. So we definitely want read. A read view for the group. The read view name. Let's see. Well, no, we definitely want to create an access list. Because it says here, also in task 3, make sure only the 192.168.1.2 server can access this. So that server right there needs to be the only person that access this device using SNMP. So we definitely need to create an access list. Access. Just like that. We'll create one. We'll call it access 1 for now. What else they wanted? Full read permissions. Do you do just read and then the name of the group? Yeah, I think we'll just do access 1. Let's see what the book said. Yeah, that's pretty much it. That's all we needed, was just the access list. Let's see here. It was version 3. Yep, privacy. But they used privacy is what they did here. Oh, SNMP 3. That's why. See? So we don't want just authentication. This is authentication, no privacy. So no encryption. This is no auth, no priv. So no encryption or no authentication. So this is what we need, not auth. So let's get rid of that right there. Privilege, or privacy rather. That's what we needed. And then the access list that we're going to create, which I'm going to create a access list number 1. Right? That's pretty much it right there. So yeah, again, if you want a full tutorial, man, I got 2 tutorials on my channel, full tutorials using real hardware and a real laptop. As a matter of fact, I explain SNMP version 2 along with SNMP version 3. So what else we wanted to do? We wanted to create an access list. We'll create that access list number 1, and we're going to permit. Who are we going to permit? We're going to permit the host name, this guy right there, or the host address, which was 192.168.1.2. See, 1.2. Any log messages or any wildcard bits, we'll do a wildcard bit, which was 000. It was /24. So the wildcard bit for that is that right there. That's going to be the access list. So only he can access it. Show access lists. Access list. And that access list is going to permit just that server, which I'm not connected to a server or anything like that. I think that's the reason why he doesn't get too deep into SNMP version 3. I think that's it for task 3. We got 5 tasks here, so we only got 2 more to go. We're going to wrap this up. Create an SNMP3 user named Ccna-admin. It will belong to the group SNMP version 3 group. Read access, and it will use SHA as the authentication mechanism, with the password set as Cisco and Cisco 123 as the DES 256 encryption key. So this is a lot here to digest here, right? Basically, they want us to create a user, right? So basically, we're gonna have a user within a group, right? Just simple, similar to Active Directory users and groups, right? So we're gonna have a user within a group, and they're going to be able to get information from this router here. Read-only access though, and that's what we gotta do. We gotta create the user. We created the group already, right? We created the group up here, right here. SNMP group, read access, and that's the name of the group, read access. We just need to create a user and put him in that group. So let's go ahead and do that. Global config mode, I know that's what we got to do so far. SNMP, most of them start with, again, with SNMP server. And if you don't know the commands, go ahead and question mark through it just like this right here. Whenever you want to decide to wake up here. So SNMP, what are we going to do? We're going to create a user, right? Just like that. See how simple that is, right? Sometimes iOS can be intuitive, sometimes it can't be. What is the name of the user? They said the name of the user was Ccna admin, all caps, right? Well, except for the admin part. Ccna hyphen admin, like that. That's how they wanted it. Next question mark is, what is the group the user belongs to? Just like Active Directory, you create a user, put him in a group, and then everybody in this group will be able to access these devices using an SNMP, and that's what we're doing here. What was the name of the group? We said the name of the group was Read Access. That guy right there, SNMP. That's the name of the group right there. Right? Y'all with me so far? Anybody got any questions? Again, I have a full tutorial on SNMP version 2 and 3. You need host 1.2. Wait, hold on. You said the access list permits the entire subnet range, not just... Oh, yep. Good catch there. So, yes. I'm permitting... Let me see. I thought I did... Oh, that's right. You know what? I should have just done all zeros there. Good catch there, Kelvin. I could do all zeros there. And that's exactly what you put right there. All zeros. So that's what I need to do. So I'm letting everybody in this range here. So I need to change that. Good catch. Good catch. Shout out to Kelvin. Kelvin Tran, if y'all want to join, subscribe to his channel. Super smart dude. And because he be catching me making my mistakes while I'm talking shit to y'all. Let's fix that after we create the user. Read access. We said we're going to use version 3. So we're going to go and fix that in a second here. Version 3. What else we wanted to do here? They said they wanted encryption DES along with SHA as the authentication mechanism. So the authentication is what? SHA, right? Is that what I said? Yes, SHA. And then what was the password? They said the password Cisco, capital C, Cisco. And then what did they want? They wanted the DES encryption key as Cisco 123. So I know it's a lot when it sets when it comes to setting up SNMP and stuff like that. That's why it's okay to kind of question mark. And now I get your point, Kelvin, on why they probably eliminated simulations, because we could just question mark our way through stuff like this, right? They did not disable the question mark. So yeah, this could be easy when you kind of like break it down like this. If they was to ask you question by question like this, it's kind of like you can process them limit by elimination to set that up. But that's probably why they got rid of simulations in the book right here. So they said they wanted the privacy, which is the encryption key, as what? DES. And what is it? The privacy is Cisco 123, capital C, CISCO 123. He said the access list. Yes. Yes, Kobe. I'm gonna correct that in just a second. As soon as we get through this part right here, the access list, which we configured incorrectly, was 1, right? Wasn't that the access list? Access list number 1. Boom. That's the access list which we configured incorrectly, and that's pretty much it. So this is the entire command that we needed. I know it's a lot to kind of digest there, but again, you can question mark your way through it. But then again, that's why they probably got rid of the sims here. So boom, we created that. Let's go ahead and fix our access list. Go to back to global config mode. Show access list. Let's do a show. Do ho access list hyphen list. Right, because we're permitting the entire subnet. We didn't want to do that. We wanted just this guy who was 1.2, right? So we're letting the whole damn subnet to get SNMP access, read-only access to this guy. Let's go ahead and get rid of that, right? So no access list 1, right? We're going to create another access list 1, permit. Who are we going to permit? 192.168.1.2. And the wildcard bits is going to be exactly 0. So we're going to say we want this exact address to get access to this server, right? Question mark. We could do some log matches against this entry, which it don't even matter because I don't have a server anyway to even test that theory out. I could have probably plugged up another router to do that though, right? Yeah, I could have plugged up another router and set him up as an SNMP server. I wish he would have done that and had 2 servers there. That's what I wish he would have done, right? Couldn't I have done that? So let's verify our work again. Show access list. And now we're permitting just this guy right here, not the entire subnet like we did incorrectly right there. So good catch there, Kevin. What else we need to do here? Task number 5, and we're going to wrap this up. Run the show SNMP user and show SNMP group commands. And finally, make sure that the right user and group settings are created. So we probably would have been able to catch that by running these show commands. Show SNMP user, and this is basically the user that will be able to gain access, read-only access from this read-only. So he can't change like say interface settings or anything like that because he only has read-only access, right? Read access right there. Well, that's the name of the group. Did I set it to be read-only? I don't think I did. I don't know. Either way, he's the only one that can access it because that's the active access list. Engine ID, don't know what the hell that means. Maybe I could look it up. That is the name of the user. Let's look it up though. Let's look it up. What's the SNMP Engine ID? Encyclopedia Brown, what does that mean? Storage type non-volatile, that's like NVRAM, right? So what if we write to this? What if we save this to our NVRAM? Will it save? Yeah, so this information will get saved if we copy run start. So that's where it gets saved to, right? I think that's what that's telling us. This is the type of authentication we're using. I'm not going to break down, too much information on authentication, but y'all can look that up. There's SHA and also MD5, I believe, is another authentication method. This is the privacy protocol that we used, and that is the name of the group that we created. So that was the SNMP user. The name of the group, he's part of the group. I guess you can't look it up that way. SNMP user. So you don't see what group he is. Oh, yeah, he is. So we got information on the user. This guy right here, he's in that group. Read access. Let's get information on the group. SNMP MP group. And that is information on the group. Oh, looks like I got some. I guess I got some groups in here. Huh. That's not by default, is it? That might be because y'all know I bought this stuff used, right? This is hardware that I bought used. I don't know. Let's do a show run real quick. Let's see. I've never seen that before. Snp. Where is that? LMI stuff there. I don't know what that is. Never seen that before. Yeah, I've never seen that before. But anyways, this is the group that we created. This is the guy we concerned with, really. That's the group name that we created. It says Review V1 Default version 3. That is the highest, it's the most secure version that you can use for Snp. And that's pretty much it, man. There's not much else on here. This is the access list that it's associated with. But that's pretty much it, man. Next time you guys want to follow along, get you a copy of this book. Tomorrow we're going to do nothing. Wait. I typically stream Monday through Thursday, 8 p.m. Eastern Standard Time. But you know what? Tomorrow, I don't think I have my daughter tomorrow. She's probably going to be with family and stuff like that. So I might do a live stream off schedule tomorrow. Which means if I do some labs tomorrow, we will stream doing Snp version 2. I don't know why he got us doing Snp version 2 in his book. What else? And configuring iOS device logging to a syslog server. So we might be able to knock those out tomorrow if I do have some time tomorrow. So good catch, Kevin, with the Kelvin with the access list there. Again, if you want to get a copy of this book, you can get it from LiveLabs.net. There's also a link in the description box below in case you guys want to follow along. It is an affiliate link, so I do get commission from it. Y'all know how much I love this book because it gives us stuff to practice our stuff, our theory hands-on. These couple labs, man, I haven't really been a big fan of these coming up, man. Snmp, I guess there's only so much he can test us with it. Snmp, what else he got on here? He gets back into some quality of service. I guess we can do some testing with that. He throws in a policy map in there. Configuring SSH. I like this lab. But anyways, again, there's 101 labs in this book. We're at lab number 72. Once we knock this book out, we're going to do some more complex stuff. More complex topologies. We're going to be doing the CCNP stuff. Stuff that my man Kelvin been waiting on because this stuff is too easy for him with these two devices. But anyways, for now, comment, like, subscribe to the network.